For question 10, there's a couple of ways you can do it. I'm going to show you the one I think is the simplest. They've got 100 cards, 1 to 100. Bill's putting a red dot on every card that has a multiple of 6 on it. So the first thing I'm going to do is just have a quick think about what the multiples of 6 are, not 9. And I'm going to use them later on. Parul puts a green dot on every card that has a multiple of 9 on it. So in the same way, I'm going to think about what the multiples of 9 are. And you'll notice that some of them match. So what it says is, Vicky's going to select a card at random out of 100. So I know that there's 100 cards. So whenever I get a probability, it's going to be out of 100. What is the probability that the card has both a red and a green dot on? So I'm looking for all the places there is a matching pair. I think the easiest way, you can just kind of figure it out in your head, but I just tend to just write down all the numbers and find where there's a pair. You've got loads of time. Especially if you know your 6 times table. You don't need to go any higher than 100, because obviously when you get to 100, that's when the cards end. I'm then going to do the same with the 9 times table. There's a pair. There's another pair. Another pair. We've reached the top. So within the pack, there are going to be 1, 2, 3, 4, 5 matching pairs. So out of the whole set, 5 out of 100 cards will have a red and a green dot on. Question 11 is a similar shapes question, actually. It's a similar triangles question. Because these lines are all parallel and the triangles meet here, you know that this triangle, the smaller one and the bigger one, are all in the same proportion. So if we want to find the value of x, we need to work with this triangle and the smaller one. So what I'm going to do is redraw them as separate triangles. I just find this helps my thinking. So 4 along there. Along this side I've got 4 and 2, so that's 6. Along the base I've got 5 and x, so I don't know this yet. For the smaller one I've got 4 and 5, and I don't know that edge. So the trick with similar triangles is there is a multiplier, a number that you times to get from the smaller one to the bigger one. So, and this applies to every side. So if I can work out how I get from 4 to 6, then I can use that to get to every other side. So from 4 to 6, you need to multiply by 1.5. Or if you like, you need to add half. So if this side is 5, if I times by 1.5 or add half, I get 7.5. So that means that this distance is 7.5. And because this is 5, x must be 2.5. So that's my first value. For y, I need to use this triangle here. So I'm going to use the larger triangle, 9, y, don't know. And I'm going to use that with one that I know the matching side. So I need to know this distance. So I can use that, and I need to know this distance. I can use that. So I now know that distance is 6. That distance is 4. Now you have to be careful here. It's this side that matches with this one. So from 6 to 9, sorry, I also know that this is 7.5. It's the same as going from 7.5 to y. 6 to 9, I'm adding half again, so I'm timesing by 1.5 or adding half. So I need to times by 1.5 or add half. Half of 7.5 is 3.75. So I'm going to do 7.5 plus 3.75, which is 11.25. And that's the value of y. Make sure you write them in here at the end, just so it's nice and clear.